The first task I requested was to put this system of equations in the form of a matrix equation. You should pause and do that if you haven't already done so. Okay, well, here it is. Here's a matrix equation. If we multiply 5, negative 4, 6 by x, y, z, we get 5 times x minus 4 times y plus 6 times z, which is the left-hand side. And since we multiplied the first row by this column, the result is going to be equal to the number in the first row of the resulting matrix of the right-hand side. Okay? And second row times this column gives us the second number. Third row times this column gives us the third number. You will be asked to take a system and write it as a matrix equation. And you will be asked on the test to take a matrix equation and write it as a system. That's two different problems. That's 2 problems out of 9. That's already 22% on your test that you should get automatically. You need to understand this, these two equivalent ways of writing the system. Now, the advantage to this way is it takes the form of a simple equation. A times big X equals big Y. Big X is not the same thing as little x. Big Y is not the same thing as little y. So I have asked you to identify X, big X, and big Y in this matrix. Before you look up to the right-hand side of the board, you should pause and write down what you think big X is and what big Y is. Okay, well, what is big X? Well, what's A? A is this coefficient matrix. Big X is this matrix. Y is this matrix. So big X stands for little x, little y, little z. It has not, big X and little x have nothing to do with each other, except, of course, that little x is one of the quantities in this column matrix. And this column matrix is big X. So little x is one number in the column that comprises big X. And big Y stands for 7, negative 1, 1, your coefficients here and here. And it has nothing to do with the little y over here. Now, we have the matrix equation then, AX equals Y. A times big X equals big Y. It should be intuitively obvious if you understand the rules of arithmetic, that if we multiply the inverse of a number by a number, we would basically cancel them out. I don't like that word cancel, but it's late in the semester, so we're going to use it. Okay, the inverse, and we talked about this on a very recent clip. So the A inverse times A more or less cancels out, gives you X. It actually gives you the identity matrix, and then the identity times X is X. And that's important, but we're going to kind of gloss over it now. We don't really have much choice at this point. So these two cancel, giving you big X. And of course, if you're going to multiply both sides of this equation by A inverse, then you got to multiply the right-hand side as well, so that big X is going to end up being equal to A inverse times Y. The result is, if we can find the A inverse matrix, because the A inverse is a matrix, if we can find A inverse, then we can multiply it by the Y matrix to find the X matrix. And the X matrix is X, Y, Z. So if we know A inverse Y, which is going to be just a column of 3 numbers, that column is going to be equal to the column X, Y, Z, so that we'll know what X is, we'll know what Y is, and we'll know what Z is. Now, we want to talk about the process of finding A inverse. So that's in the next clip.